Must know number 6. Mixed and improper fractions. So there are actually 3 main types of fractions: proper, improper, and mixed. Now let me quickly tell you the difference between the 3 of these and then how we can convert between them. A proper fraction is of the format a over b, where the number in the numerator, a, is less than the number in the denominator, b. And then a quick example of that would be the fraction 3 over 5, where an improper fraction is also of the format a over b, but this time the number in the numerator, a, is bigger than or equal to the number in the denominator. So an example of an improper fraction would be the fraction 10 over 7. And then a mixed fraction looks like this format, where we have some whole number c, and then beside it we have a proper fraction a over b. And then an example of a mixed number could be the number 2 and 5/8. And it's also worth noting that in this notation, let me zoom in a bit, this is not 2 times 5/8. It's actually 2 and 5/8, or a better way of putting it is 2 plus 5/8. So now let's work at converting between a mixed fraction and an improper fraction. So for example, if we had the mixed fraction 4 and 2/5, we can actually write that as an improper fraction by finding the product of the whole number and the denominator, 4 times 5, and to that product, add the numerator of the proper fraction, so add 2, and put that all over the denominator of the fraction, which is 5. And then this would simplify to 4 times 5 is 20, plus 2 is 22, over 5. So if I were to write this rule out in words, to get that improper fraction, I do the whole number of the mixed fraction, multiplied by the denominator of the fraction, and then add the numerator, and put it all over the denominator of the fraction. If you forget this rule, what you could actually do is you could just rewrite that mixed fraction. You could rewrite it as an addition question if you wanted to. You could write it as 4 plus 2/5. And 4 is actually 4 over 1. And if you got a common denominator by multiplying this fraction by 5 top and bottom, this would equal 20 over 5 plus 2 over 5, which is of course 22 over 5, which is the same value we got using the rule for converting from a mixed to an improper fraction. So I'll erase that and we'll go ahead and try and go the other way. What if we wanted to go from an improper fraction to a mixed fraction? Here's an example. I have the improper fraction 8 over 3 and I want to write it as a mixed fraction. To do that, I actually have to be able to do a division. I need to do 8 divided by 3 and see what my quotient and remainder are. So I could set up a long division table, and then 3 goes into 8 2 whole times. 2 times 3 is 6. And then when I subtract what's in my dividend, I see that I have a remainder of 2, which means that 8 over 3 can be written as, well, it goes in 2 whole times, and then because my remainder is 2, it goes in 2/3 of another time. And the rule I'm following to write that as a mixed fraction is I'm writing the quotient as the whole number of the mixed fraction. So in this case, my quotient was 2, so that becomes the whole number. And then the proper fraction that goes with that mixed number is the remainder over the denominator of the fraction. Since my remainder is 2, I put that over the denominator, which was 3, to get 2 and 2/3. Must know number 7. Percent. A percent is a special type of fraction where the denominator is 100. And the percent symbol just means parts per 100. So let me show you how we can convert a percent into a fraction and vice versa, a fraction into a percent. Let's start by turning a percent into a fraction. So let's say we had 75%. This percent symbol means that we have 75 parts per 100. So I could write this as a fraction as 75 over 100. And then that fraction can be reduced. The greatest common factor between 75 and 100 is 25. So I can divide both the numerator and denominator by 25. And that would give me the equivalent but reduced fraction of 3 over 4. Now how about if we start with a fraction and want to convert it to a percentage? Let's say we have the fraction 3 over 20. If you'd want to convert this to a percent, the first thing you'd want to do is convert it to a decimal value by doing the division. You could do 3 divided by 20, and you could do that using a calculator or by doing long division. And you would find out that its decimal value is 0.15. And to get a decimal value converted to a percent, all you have to do is multiply it by 100, which would make this equal 15%. Now, this middle line is a little bit misleading. What's actually happening here is that 0.15, if we were to think of that as a fraction, it's 0.15 over 1. And to be a percent, we know we want the fraction to be over 100. So we would need to multiply the top and bottom of this fraction by 100. So really we're multiplying it by 100 over 100, which would make it equal to 15 over 100. And we know when we have a fraction that's over 100, we could write it as a percentage. 15 over 100 is 15%. But usually all of these steps aren't communicated. You just have to know that if you have a decimal value and you want to convert it to a percentage, just multiply that decimal value by 100 and it gives you the percent value of that decimal. The other way you could convert a fraction to a percent, let's work with 3 over 20 again. Because we want this fraction to be over 100 so we can express it as a percent, I would just notice that I could make 20 be 100 if I multiplied it by 5. So I could just multiply the top and bottom of this fraction by 5. And that would give me the fraction 15 over 100, which is 15%. Must know number 8. Equations involving fractions. I'm going to solve 2 equations that both involve fractions. And before we solve these equations, let me give you a tip. When solving equations involving fractions, you can just multiply both sides of the equation by the lowest common denominator of all the fractions to eliminate them. So let's start with example 1, where I see I have 2 fractions that are equal to each other. The denominators of the fractions are 5 and 3. So one option I have is I could get rid of those fractions by multiplying both sides of this equation by the lowest common multiple of 3 and 5. If I were to list the multiples of 3 and the multiples of 5, I would see that the lowest common multiple between 3 and 5 is 15, which is also the product of 3 and 5. Find the product of the denominators will always find you a common multiple. It just might not always be the lowest common multiple. So what I can do is multiply both sides of this equation by 15. And now on the left and right side of the equation, I have a product of fractions. So I can cross reduce. 15 divided by 5 is 3. And 15 divided by 3 is 5. So notice my fractions are gone now. On the left side of the equation, I just have a 3 times x. And on the right side of the equation, I have 5 times x minus 2. And there's actually a shortcut for this question. If you had have noticed that we had a fraction equal to a fraction, you could use a method called cross multiplication to jump right to this step. All you would have to do would be to find the product of one denominator with its diagonally opposite numerator and set one side of the equation equal to that product. And then the other side of the equation would be equal to this denominator times its diagonally opposite numerator. So 3 times x is what the other side of the equation is equal to. But only use that shortcut if you have a fraction equal to a fraction. And now we need to solve this equation. So I would use the distributive property to expand the right side of the equation, which would give me 5x minus 10. And then I would continue solving by getting the variable terms to the right side of the equation and the constant term to the left side of the equation. So I have 10 is equal to 2x, which means if I divide the 2 to the other side, I would find out that x is equal to 5. And don't forget, when solving any equation, you can check your answer by subbing it back into the original equation for x and make sure left side equals right side. Let's now try and solve equation number 2. I see 3 fractions. So what I can do to get rid of those fractions is multiply both sides of the equation by the lowest common multiple of all of the denominators. The lowest common multiple of 2, 3, and 6 is 6. So I'll multiply both sides of this equation by 6. On the left side of the equation, I'll have to distribute the 6 to both terms. And now I can start reducing these fractions. 6 divided by 2 is 3. 6 divided by 3 is 2. And 6 divided by 6 is 1. So So on the left side of the equation, I have 3 times x plus 2 times 1. That's just going to be 3x plus 2. And then on the right side of the equation, I just have 1 times 1, which is 1. I'll isolate the variable term by moving the 2 to the other side. So I have 3x being equal to negative 1. And then if I divide the 3, I find that x is equal to negative a third. Must know number 9, fractions in the exponent. So in this section, I want to show you what to do if you have a power with a rational exponent. And the rule, if you're taking the nth root of a power a to the m, this can be written as a power with a rational exponent, where the base is still some number a, and the exponent becomes the fraction m over n. So let me give you a few examples where we can work with some powers with rational exponents. Let's start with example 1, where I have the power 8 to the exponent of 2/3. If I wanted to evaluate this without a calculator, what I could do, using my exponent laws for a power of a power, I could rewrite this as 8 to the power of 1/3 squared. And then when evaluating 8 to the power of 1/3, what that means is 3 factors of what number multiplied together is equal to 8. Well, I know 2 times 2 times 2 is 8, which means 8 to the power of 1/3 is 2. So we have 2 squared, which is 4. In example 2, I have the 4th root of this fraction. I can rewrite that expression as a power with a rational exponent. It would be 16 over 81 to the power of 1 over 4. This small number with this root symbol is called an indice of the root, and it becomes the denominator of the fraction that's in the exponent. And then using my exponent rules, I know that exponent of 1 over 4 would be applied to both the 16 and the 81. And an exponent of 1 over 4 just means 4 factors of what number multiplied together is going to equal the base of the power, 16. Well, 4 factors of 2 multiplied together is 16, so my numerator is 2. And in the denominator, 4 factors of what number multiplied together is 81. Well, 3 times 3 times 3 times 3 is 81, which means 81 to the power of a quarter is 3. So the 4th root of 16 over 81 is 2/3. And then example 3, I have a y squared that I'm taking the 5th root of. That 5th root symbol can be rewritten as a rational exponent. I could rewrite this as y squared to the power of 1 over 5. And then using exponent rules, I could multiply those exponents together to get y to the power of 2 over 5. And similarly with example 4, I need to do the 4th root of x cubed y squared, which means I would have x cubed y squared to the power of 1 over 4. And when you have a power of a product, that exponent applies to both factors of the base. So I would have x cubed to the 1/4 and y squared to the power of 1/4. And multiplying the exponents together, I would have x to the 3/4, y to the 2/4. But of course, 2/4 could be reduced to a half. Must know number 10, rationalizing the denominator of a fraction. In this section, I'm going to show you how you can rewrite a fraction so that the denominator no longer contains a radical. And there are 2 main ways we can rationalize a denominator. I'll give you an example of both. Looking at this fraction in example 1, I see the denominator is the square root of 5, which is an irrational number. But typically in our fractions, we want the denominators to be rational numbers. That's why it's called rationalizing the denominator. And how we can do that is we can multiply top and bottom of this fraction by the radical that we have in the denominator. So I can multiply top and bottom of this by root 5. So I'm multiplying this by root 5 over root 5, which is just 1. So we're not changing the value of the fraction. But when I do the multiplications, in the numerator, I have 3 times root 5, which I would just write as 3 root 5. That's an irrational number still, but that's okay. In the denominator, I have root 5 times root 5, which is the square root of 25. And the square root of 25 is the rational value 5. So this fraction has the exact same value as 3 over root 5, but the denominator is now a rational number. So the denominator has been rationalized. Now let's look at example 2, where in the denominator, we still have this irrational number root 5, but the denominator is now a binomial. It's root 5 plus 2. The strategy when we have a binomial in the denominator that needs rationalized is called multiplying by the conjugate. And what that would look like, we would multiply top and bottom of this fraction by this same binomial, but we would change the sign. So instead of plus, we're going to write minus. And then in the numerator, I have 3 times root 5 minus 2, which I'll just leave it as that product. And then in the denominator, I have root 5 plus 2 times root 5 minus 2. That's actually a difference of squares. And in case you don't remember the rule, I'll write it up top here. If you have an a minus b times an a plus b, if we were to expand that out, it would simplify to just a squared minus b squared. And that's exactly what we have with this product. The binomials look exactly the same, but their signs are different. So I know when I do the multiplication of root 5 plus 2 times root 5 minus 2, it's going to equal the square root of 5 squared minus 2 squared. And then if I simplify this fraction in the numerator, I could distribute the 3 to give me 3 root 5 minus 6. And in the denominator, I have the square root of 5 squared. Square rooting and squaring are inverse operations, so they're going to cancel out in this circumstance, and that's just going to be 5. And then I need to subtract 2 squared, which is 4. So notice the denominator is now a rational value. The denominator is now actually just 1. So my final answer would just be 3 root 5 minus 6 over 1. But when dividing by 1, we don't have to write it because it doesn't change its value. So my final answer is just 3 root 5 minus 6. So hopefully if you followed along with this whole video, you feel a lot more comfortable now working with fractions and you understand how they work. Let me know what you want a top 10 of next.